Welcome to the first episode of the online chemistry class. In today's chemistry class, we shall be having a revision lesson using some past examination questions. We are going to review questions relating to atoms. Your chemistry teacher is Dr. Joseph Coker. Please have writing materials to take notes as you watch this lesson. If you have any questions about the topic, click on the blog section of the website and post your questions. We shall get back to you as soon as possible. I will now be handing you over to your teacher, Dr. Coker, who will take you on the lesson. Have a happy viewing.
We are looking at chemistry for secondary schools. And my name is Joseph Coker. This will be a revision lesson, and the aim is to revise what we have done in chemistry from the first year. Basically, this revision will be based on question solving. And the first topic we want to look at is atoms. And question 1 from SSCE November 1994 says, give the names and the relative masses and the charges of the fundamental particles that make up the atom. We need to know that this question demands three major items of the fundamental particles that make up the atom. Recall that the fundamental particles are proton, neutron, electron. And the relative mass for proton is 1 atomic mass unit. For neutron is 1 atomic mass unit. An electron is 1 over 1850, that is 1850 atomic mass unit. For the charges, proton is positively charged, so we indicate it as +1. Neutron has a charge of 0, that is to say, it is neutral, that is no charge. And electrons are negatively charged and has a charge of -1. Question 2. State 2 postulates of Dalton's atomic theory which had later been disproved. What is the structure of the atom proposed by Rutherford? This question is extracted from SSCE November 1995. Now let's recall Dalton's atomic theory. 1. Matter are made up of small particles called atoms. 2. Atoms can neither be created nor destroyed. 3. Atoms of the same element are identical and equal in size and in mass. 4. Atoms of different elements have different size and mass. 5. Atoms of elements combine in simple ratio of whole numbers to form compound. Now, if we look at these 5 postulates, The student should know that only postulate 2 and 3 were disapproved. Hence, by the demand of this question, the student will only state these 2 postulates. Let's recall the question. What is the structure of the atom proposed by Rutherford? Rutherford stated that the atom has a central core called the nucleus, which has positively charged particles called the protons and neutral particles called the neutrons. Electrons, which are negatively charged, orbit around the nucleus. And if you recall, the mass of the electron is 1/1850. So they have a negligible or very small mass compared with the protons and the neutrons. Question 3. Distinguish between protons, neutrons, and electrons. Show the relationship, if any, between protons, neutrons, and electrons, and the atomic mass of an element, i.e. the mass number of the element. This question is taken from GCE A-level. Now, to summarize the first part, where we are to distinguish between the proton, the neutron, and the electron, I put it in a table form. So the name, as we earlier on look at, proton, neutron, and electron. Again, recall, the relative mass for proton is 1 atomic mass unit. For neutron is also 1 atomic mass unit, that is AMU. And electron is 1/1850 atomic mass unit. The charge +1 for proton, 0, that is to say neutral, for neutron, and electron has a charge of -1. And the location in the atom, protons are in the nucleus of the atom. Neutrons are also found in the nucleus, and electrons are around the nucleus. Representation: proton, as indicated, P, has mass number of 1, which is the number up, otherwise is superscript, and atomic number 1, which is down, that is the subscript. Neutron, represented as N, has a mass number of 1 and atomic number of 0. Then electron, represented as E, has a mass number of 0 and atomic number of 1. Now we are to define atomic mass of an element is a number of protons present in the nucleus of the atom. Again, the atomic number of an element is the number of protons present in the nucleus of the atom. If the atom is neutral, that is to say, it doesn't have any charge on it, then the number of protons is equal to the number of electrons. The mass number of an element is the sum of the number of protons and neutrons present in the nucleus of the atom. So if you know the number of protons and the number of neutrons, you just add the two to get the mass number.